Folks, we are discussing cooking with cooking oils and fats. And, we hear the advice online that you ought to use saturated fats when you're frying or cooking in high temperature because the fats are more stable and they don't produce trans fats like the oils do, cooking oils do. This is take two for Dwayne and I because the
Yep.
recording got messed up, but that's okay. Hopefully, we can streamline this a little bit from last time, huh?
I memorized everything I said, but then I forgot it.
We don't want that. My big old face. My face on my big old face. All right, so we got a few studies to get through here. First one is the effects of heating and reheating of fats and oils used by Asian Indians. So this is done in India on trans fatty acid formation. So looking through this, what they did is they contacted some home women who cook at home, which is what we're concerned with, when people talk about this topic here. They also, right up here in the top right, contacted some commercial eating outlets. So this would be restaurants and roadside food vendors and stuff like that. And they got common oils that these people used. And then what they did is they had kind of two arms. So on the left side here, we have the heating protocol, which is just the oil. So they put the oil in an oven and they heat it up to a certain temperature. And then they did the same thing with the frying protocol. The frying protocol, they put it in a skillet or a pan to deep fry, and they fried up some French fries. So what we have is both arms of the trial are pretty much identical. It's just one is heating it up in the oven and the other one's frying something in a pan. So they put 500 milliliters of fat or oil, heated it to 180 degrees Celsius for 30 minutes, took a 30 milliliter sample, heated up to 220 Celsius for 30 minutes, took a 30 milliliter sample, and then they allowed those fats and oils to cool for 60 minutes. And then they redid that heating process and took their samples. And so what did they find here? We have our fatty acid profile of the pre-fried French fries. So these French fries are pre-fried, they're partially cooked, and then they're frozen. So this would be just like you would get at McDonald's or Burger King or any fast food restaurant. That's how they order their French fries. They're pre-fried, partially heated, and then they're frozen. And so when you work at the fast food restaurant and you get orders for fries, you get those frozen fries out, you dump them in the basket goes in, you hit the button, and it all has an automatic timer on it, right? And so looking at our pre-fried French fries, the trans fatty acid formation in the pre-fried is 0. It's undetectable. So that's good news for French fry eaters.
Right.
Right. And so then what we have in this trial, the fats and oils, we have sunflower oil, groundnut oil, olive oil, rapeseed oil, partially hydrogenated vegetable oil. Partially hydrogenated vegetable oils are banned in the United States now. And then we have clarified butter or ghee. And in the blue here, this is unheated. And so for our first three oils, we can see that the levels of trans fatty acids were undetectable. For the rapeseed oil, it was 1.6 grams per 100 gram. Partially hydrogenated vegetable oil was 13, about 13. And then the clarified butter was about 0.7. And then we can see our heating and our reheating cycles and what those did to our trans fatty acid contents. And this chart here specifically for the frying, and we can see that trans fatty acids did indeed increase in all of these fats, all right, even the clarified butter. And we can see that the heating, the initial heating of 180 Celsius or to 220, didn't tend to produce high levels of trans fatty acids. But once we get to the reheating part, we see the trans fatty acid content jump up pretty significantly. And then most notably here in the partially hydrogenated vegetable oil from, unheated, we go from 13 to reheated up to 220, we go to about 19 grams per 100 grams. And so, keeping this in mind, we look back at the trials that we have covered so far, like the Minnesota coronary experiment and the Sydney diet heart, where the participants were consuming partially hydrogenated vegetable oils. And we look at the trans fatty acid content coming from these things. And of course, we can see that, yeah, this would be a significant confounding factor in those. And then,
Right.
interesting enough here, the clarified butter, we went from zero point 0.7 to 3.28. And so the idea here, even at each step along the way, the idea would be, well, you should be cooking in the clarified butter because it's more stable at these higher temperatures, higher smoke point. You won't be forming these trans fatty acids because it has less linoleic acid, and that's supposed to be prone to oxidation, and that's what causes the trans fatty acids. But we can see that's not the case in this trial here.
Yep.
On
Yep.
par with all of the other oils. So
Yep.
significant. And then so we can see in this column here, we have the relative change. So the percent it changed. And of the three that we have that data on, the clarified butter actually increased the most.
Yep. Huge.
So yeah,
By the way,
that's that.
220 degrees that's like almost 430 degrees
It's
Fahrenheit.
yeah, these temperatures are piping hot.
Yeah. So what's interesting is the initial heating, there's an increase, but not the
Mm-hmm.
same as when you go back to reheat it. There's some serious chemistry going on there.
Mm-hmm. Yep. And then the same thing for the baking. So where they just put it in the oven and they just heated it, we
Yep.
see right on par with the frying. So it didn't seem to make a difference, um, how much, whether they fried something or whether they just put it in an oven and heated it up. So yeah, clarified butter did not reign supreme in this
Nope.
trial here.
Nope.
Yeah. So that's our first one. Moving on to our second one, oxidative changes in some vegetable oils during heating at frying temperatures. And so for this one, they looked at a few different things. And this trial, they looked at heating to 180 degrees Celsius. All right, so just like the other trial. And what they looked at here, we have sunflower oil, grape oil, soybean oil, corn oil, and olive oil. And so in the red square here, we looked at the induction period. And what that means is right here, the oxidation stability. So basically, how stable these fats are at 180 degrees Celsius for a certain amount of time. And down here, we have in hours. And so the longer that temperature was held for these oils, we can see that this induction period dropped. Okay, so once this line that starts on our y-axis here drops down to our x-axis, the fat is no longer stable. And we can see that olive oil here seemed to do the best. Sunflower oil did the worst. However, in terms of what we're concerned with at home, like under 1 hour, all of them were fine, right?
Yes.
So
Yes.
we're
Yes.
really looking at, sunflower oil, it took here somewhere on the order of 12, 13 hours to reach this 0 point. And then the olive oil was over 50 hours. So olive oil did really well.
Yep.
The
Absolutely.
next graph here, we're looking at conjugated dienes or dienes. I don't know what that is. But this would be the formation of kind of the precursor molecules to trans fatty acids. And so again, heating time on the x-axis here in hours, and then the content of conjugated dienes here. And we can see olive oil did the best again. Sunflower oil did the worst again. But in terms of what we're usually cooking with at home, so under 1 hour, we can zoom in here. We can see them all, pretty tightly held together down here on
Right.
this y-axis, right? So we're really concerned with less than 2 hours or under. I mean, you're not really cooking this stuff longer than that.
There's very few things you're going to cook longer than that. Maybe
Mm-hmm.
a turkey or something, but that's not what we're talking about.
Yeah. And then our last chart here, let me zoom in on this a little bit. All right. Change in total polar components. And so this is looking at uh, the change of certain molecules to other molecules. And in Europe and other countries, this is actually a a looked at thing. They actually have a cap at about 25%. So once the total polar components within a fat or oil reaches 25%, by European standards, you can't use that oil anymore. And so, according to heating time, what we can see here is, again, olive oil did the best, coming over here over 40 hours, 43 hours, something like that. Sunflower oil did the worst. But again, with what we're concerned with at cooking at home, less than 1 or 2 hours, everything was held together here between 5 and 10%. So nothing really to be concerned with on these total polar contents. All right. So it did take over 50 hours over 40 hours for a couple of these things, the olive oil and the corn oil, to reach that 25% threshold, right? And we can see that 25% threshold and the hours for each of the things here, for each of the oils. All right. So staying on the topic of total polar components, we have here a study on tallows heated under deep frying conditions. And so this actually looked at, well, what happens to beef tallow when we put it in stainless steel deep fat fryers and we use that for making French fries, a relevant topic to today.
Absolutely.
So, what happened? Well, we can see that the percent of total polar components actually increased. And in more than a few of these, it increased to those levels that we would be relatively concerned with here. And so the trials we looked at so far, we're looking at 180 degrees Celsius or 200 degrees Celsius. And so for here, we can see a few of these. So like this is 173 degrees Celsius. So a little bit cooler temperatures, and that reached 19%. Here we have 146 degrees Celsius, and that reached 30%. And we have 20 and 21. And these were right around 180, 182, and 184 respectively. So what's happening in the beef tallow here is the cholesterol that's in it is being lost and being changed to these total polar compounds. Um, I'm sorry. These were the polar compounds before heating. This is the polar compound formed by heating, and we can see,
Holy moly.
27%, 18.4, 20,
Yep.
19.2. So reaching the same amounts that we're seeing in the other oils for about the same amount of cooking times. So this idea that beef tallow is going to last longer in a deep fryer doesn't seem to be supported by the data here. All right, I mean this is one study; it's a little old, but it doesn't appear to hold up to what's being said.
So I think right about here in the lost recordings,
Hmm.
I have brought up the point of anecdotally, I know several guys that work in the food industry, and many of the restaurants that you people would recognize right off the bat, if I said them, they are aware of the multiple heatings and
Mm-hmm.
the changes in those compounds, and they will cycle out their
Mm-hmm.
greases and oils. Not everybody does that, but a lot do. I'm not going to say the majority, but I'd say more than half, because they've recognized that the reheating changes the compounds, just
Mm-hmm.
like we showed in these charts. So that's interesting to know.
Yeah. It does the reheating thing we're going to see seems to be a big factor here. So this
Yeah,
one here, we're
absolutely.
looking at canola oil only. And what they did is they made zucchini cakes or ginger snap cookies, and these were baked at either 180 Celsius or 200 Celsius. And then they had a stir-fried chicken that was prepared at 200 Celsius and 275 degrees Celsius. So
Holy cow.
this is stir-fried, so you're frying it up in a pan. And so
That's
what?
527
Yeah,
degrees.
that's hot, Betty. That's
Wow.
super hot. All
Call
right.
the
So
fire
the
department.
formation of trans isomers, so trans fatty acids, in our zucchini cake, baking at different temperatures. So on the left, this grid pattern here is just the dough. That's before heating. The blank bar, the white bar, is 180, and then the diagonal stripes is 200. And we can see that the total formations of trans fatty acids really didn't. It went up, but not significantly. Right. Just nothing to write home about here on
Hmm.
the zucchini cakes. On the ginger snap cookies, pretty much the same thing. I mean, there's a change. Something's definitely happening. Is it enough to be concerned about? Not really. As we look at the contribution as a percent here on the left, it goes from 2.75 to 2.9.
Yeah, maybe 8.
Same thing, even less on this one. So, I mean, nothing really happening here. And then, same thing for our stir fried chicken. So, of course, we obviously do see a stepwise increase in the frying versus the baking.
Hmm.
But even at 275 compared to 200, it just, the total amount of trans fatty acids in here isn't alarming.
Hmm.
It's just not getting up. What you would hear on the internet is this stuff should be just chock full of trans fatty acids. I mean, just artery clogging levels. And it's just not. It's just not changing that much.
Right, right. Absolutely.
All right, getting down to the last of them here, investigating the thermal stability of omega fatty acid enriched vegetable oils. So these oils are enriched with omegas, whether it be 3, 6, or 9 omega fatty acids, but they looked at enriched fatty acids, and the omega 3s would be something we would want to have, and you would hear a lot online that those would add to the stability. However, looking at the chart here, we do see so a lot of these are different versions of sunflower oils, and then we have some different versions of olive oil and a couple other things in here, right? So, but what we can see, what they did in this trial is they heated these oils up to different temperatures, so 180, 200, 230, and then they held those for 30 minutes, 60 minutes, 180 minutes, and 360 minutes. Now, just looking at the chart here, it would be pretty easy to paint the picture that, well, this is alarming, right? We could just see this stepwise linear increase as the temperature goes up and as the amount of time that we hold these things to. However, looking at the left-hand side here, again, these are trans fatty acid composition as a percentage of the wet weight of this. And so looking all the way on the left here, the dark blue on the left of all of these is the room temperature. And then the right hand side would be 230 degrees for 360 minutes. That's 6 hours, folks. 6 hours. And when we can see the change between room temperature and 230 degrees for 6 hours is about 1.25%. That's the amount of change that we're seeing on pretty much all of these, which just isn't that much.
Hmm.
The alarm just isn't there on this. Okay.
Right.
So far we are seeing that there is a change due to temperature, and there seems to be even more of a change due to reheating.
Yep.
All right.
Absolutely.
And this is happening even in the saturated fat containing cooking fats. So this last study here, we're looking at a few different oils: palm oil, soybean oil, rapeseed, sunflower, and olive oil. And what they did for this trial is they heated these up to 180 degrees, I believe. And then they did that for either one time, 5 times, or 10 times. All right. So they heated it up to 180 degrees, held it there for, I forget how much time it was. And then they repeated that process one time, 5 times, or 10 times. So what we look at here is the change in linoleic acid values. And we can see that with each increase in heating cycles, we do see a decrease in linoleic acid values. But again, it's just not that much. there's not a lot happening here. All right. These oils are staying pretty stable. Same thing for the decrease in ALA. That would be the plant-based version of the omega-3s. Stepwise decrease in most of these. Sunflower oil did pretty well. Extra virgin olive oil did pretty well. But again, as a percent of wet wheat, the change just isn't that much as a percentage, right? So the total amount of change happening here isn't anything to write home about. And we can see the change in trans fatty acid values. And with each increase in the number of reheats, we see an increase in trans fatty acids. So it doesn't seem to be that the temperatures are driving a huge amount of change, but the reheats really are what is driving the change. So concerning us at home, this would tell us like, well, it's probably perfectly fine to cook with whatever fat you really wanted to, for a given dish. But when it comes to reheating stuff, which most people normally don't do at home unless you have a deep fat fryer and you're just kind of leaving the oil in there and
Mm-hmm,
reusing
mm-hmm.
it, then that may come to be of some concern. So reheating it one time, probably not a big deal. Reheating it 5 times, we start to see a difference. Reheating it 10 times, it starts to become much more significant here at 10 reheats. So what they did in this study, they went a little bit further, and they not only measured these changes in our fatty acids, but then they also plugged these values into a couple of different indexes. So we have index of atherogenicity, so how potentially atherogenic these oils are, and then the index of thrombogenicity, so how much potential to induce thrombosis, which is blood clotting, would these oils have. And so looking at the palm oil, which would have the saturated fat, the most saturated fat content, the where it scores on the index of atherogenicity and thrombicity is way up there compared to the others. Extremely high. And we can see rapeseed oil here had the lowest. So even at room temperature before heating, it was a 0.049. And then even at our 10 reheats, it was a 0.052. So canola oil, rapeseed oil, doesn't seem, even though we see this increase in the trans fatty acid content, doesn't seem like it's going to be very atherogenic, probably because the total amount of trans fats that are happening in there just isn't that much.
Right, right,
All right. And then the same
right.
thing for the thrombogenicity. Rapeseed oil seem to do the best, and our
Mm-hmm.
other oils fared relatively equal to each other. But the saturated fat containing oils, as we look through our studies here, the saturated fat containing oils didn't do better. So the idea that swapping out vegetable oil to any given animal fat or even coconut oil or palm oil doesn't seem to hold any water as far as like an issue regarding smoke point or the fact that it's going to withstand temperatures and be more stable. The data just doesn't bear that out. So I think big takeaway here is you can use whatever you want to cook with. I've mentioned it several times. So there's things that I like to cook with olive oil. I said it last time, right? So you put some tomatoes and some asparagus and
There we go. Come on,
and some
come on.
onions and a
Yes.
big block of feta, and you just
Ah,
douse all of that in olive oil.
mm,
Throw you some salt and pepper on there and some Italian seasoning and bake that
mm,
dude.
mm,
Good
mm.
to go. When I cook my tofu, though, when I pan fry my tofu, I like to use canola oil or soybean oil because I don't like the taste that the olive oil leaves in there on that, right? So you do whatever you want. If you wanted to cook your eggs in a little bit of butter, probably going to be fine, all right? You don't have to use oil if you don't want to. You also don't have to use butter if you don't want to. So as far as, cooking stuff in all these different fats and the formation of trans fats doesn't seem to
bear out.
There's not a large of a difference between all of these different oils and fats. So
right.
as long as you're not reheating your oils, good to go. That's it, man. Did we set a record?
I think we might have. Yeah, I realized half the stuff I said last time wasn't really important or relative. I'm just the everyday ombudsman, man.
Everyday man ombudsman. All right, well, that's it. Let's keep it short and sweet. Hope you guys got something out of this. Hope some minds were blown. And we'll see you all next time. Coach Lambie, Dwayne out.